students, and this is Coach Powers. This is Science with Coach Powers, and we're going to look at Unit 1, Safety in the Chemistry Laboratory. Please pay attention to calendars when things are coming up, and please subscribe to YouTube channel, the Twitter page, the please, and remind.com. So let's go right into it. I'm going to share our presentation. You'll find this presentation also in Virtual SC. You can use this video to reference back. I have chapters that are located. This is going to be 1.123, and 1.1 is technically your study guide. So I'll go ahead and present this, and hopefully it comes up, and it should. Okay, so that's Unit 1, Safety in the Chemistry Laboratory. Hopefully you'll see that as well. So now, basically, nobody expects to walk into a classroom, all right, or a laboratory and leave in an ambulance. Okay, sounds pretty drastic, I know, but there is every year in a lab, and I haven't seen one in my class, an injury that are preventable and for accidents. Here are a few thousands of lab accidents that made the headlines in the past few years. 2009, California student without a lab coat was burned to death. How morbid. 2010, a Texas student was hospitalized with facial lacerations after a chemical reaction exploded in a glass container. 2011, an Illinois high school junior suffered a permanent blindness when a closed container of dry ice exploded. 2012, in San Francisco, a young man died being infected with a deadly strain of bacteria he worked with in the lab. 2013, 13 Colorado lab students were hospitalized after breathing titanium tetrachloride fumes. I flash forward to 2014. 2 New York students badly burned, disfigured. Teacher used too much accelerant in the lab. You don't know what accelerant is? It's like adding lighter fluid to a fire grill. So you can see that might be an issue at home. So you're learning good home skills. 3 students in New Jersey, 2015, were hospitalized after inhaling toxic fumes after a chemistry reaction gone bad. And every single one of these can be preventable. And basically, I'm reading off what Virtual SC has come up with. But some of this is common sense. Some of this is, hey, let's just get this done. I don't want to look bad in front of my classmates wearing, you know, a hairnet or goggles or things like that, because it doesn't matter how you feel as how you look, right? So by the end of this lesson, you should be able to distinguish safe chemistry practices from unsafe chemistry practices. And some of it is common sense, and some of it is just not knowing what these things or what chemicals can do, or what the lab experiment is all about. It's almost an ignorant way to look at things if you don't know what you're getting into and prepare for a lab or listen about what's happening. Okay, so 1.1, the chemistry laboratory can be an exciting place to discover and learn. It can be. It can quickly turn dangerous, of course, and you have some safety rules, and that's why we present those every year in a lab setting and have tests and quizzes about what to do, just like this. It's everyone's responsibility to take training very, very seriously. If one student becomes careless and with a concentrated acid like HCl or hydrochloric acid, sulfuric acid, all the above, an open flame, nearby students can be burned, scarred, or otherwise injured. So this is the deal. The comic reads, and to think I was used to wonder why I was underpaid. The student says, I take it we weren't supposed to shake the vial that said do not shake. Egad, my pants are dissolving. This is the deal. If you don't know and forget, just put on every protective gear you possibly can for that lab. That's the kind of thing I go off of. When in doubt, prepare, hope for the best, prepare for the worst. When I was a lab chemist, an environmental science corporation, I often work with sulfuric acid and look for cyanide fluids in field samples and things like that. I ended up with a lot of Swiss cheese sweatshirts, even though I was wearing a lab coat. And burned hands and stuff like that. So I can still use my hands. I was a college basketball player. I was doing that concurrently. So anyway, let's move on. All right, so there's my favorite dude here. Hank Green, Crash Course, takes a break from the desk and basically points out some practical chemistry. And this course, Crash Course, is in your virtual SC. I'm not going to take you through a video within a video. So I like using Crash Course. He's another good educating video YouTube guy, and is doing really well. Now, of course, you're going to see in this video some vocab and things you're going to have to know. The MSDS sheet, Material Safety Data Sheet, maybe even the OSHA regulations at some point in your life, hazmats and symbols and signs and things like that. And this is a question you'll see. I'm not going to go through the questions. This is a virtual essay. These are your assignments you're going to have to do. 2 lab safety violations these girls are committing. So look at the picture, answer the questions. Of course, I have to read through those and grade them. Look at this dude, say, okay, what is this dude doing wrong as far as walking into a lab? You can imagine the things that students commented on less than respectfully to me about why do I have to wear this? And, you know, there's some backlash on this, but, you know, it is what it is. And that's why some students are hesitant to take chemistry labs in classes. I took several in college, and you may as well. Here's a question. Your lab partner, again, I'm not going to read through these questions. It talks about what do you say to your lab partner? Okay. Trudy walks in the lab, and basically, what should you tell her if she's drinking something in the lab? Another question. So you notice there's a symbol right down here. You're going to have to know what these symbols are, and data sheets will be able to tell you, or reference sheets will be able to tell you, hey, this is what these are. This is what number the 3 blue means. This is the 1 red, 0 yellow. What levels is it? Number 1 is bad, or number 5 is not bad, or is it number 1 is good and number 5? You got to know that kind of stuff. And I'm leaving that for your own research and study. If you have questions, there's office hours, as you know. More questions for you. These are short assignments. Looks like there's 12, and then we get into 1.2, the safety data sheet, the MSDS, the material safety data sheet. So if you want, stop it here, pause it here, go back and do the questions. Okay, so moving on to 1.2, the safety data sheet, MSDS. All right, so how many of you know what carbon tetrachloride is? All right, there's 4 carbons. There's 4 chlorides and 1 carbon. All right, CCl4. All right, so what about naphthalene? Or some countries pronounce it differently. I should probably speak in an English accent because I sound more, credible. Ammonium perchlorate. Are these solids, liquids, or gases? Are they flammable? What if you inhale them? What if you spill on your skin? You're gonna freak out. Don't freak out. Just be calm-headed as you possibly can, because things don't go well if you don't. So if you look down here in this lesson, you will explore the MSDS, or the Material Safety Data Sheet, a document prepared for every chemical, and a document students must read before you ever enter the lab environment. How many of you do that or have done that? Even the bottle, sulfuric acid, will have some information for you. And there are these data sheets in each classroom in high school or college. They have these references. And sometimes it's at your own risk, because I was left alone in many college settings, in lab settings, because you have to go during the time you're available. And there was no professor in the lab at the time, but they trust you. There's a lab assistant somewhere in the building preparing stuff. All right, so by the end of the lesson, you'll also be able to examine scientific investigations by using appropriate laboratory equipment, technology, techniques, and safety procedures to collect qualitative and quantitative data. Now, quantitative, how much of something, a quantity of something, you're counting it. Qualitative is what it looks like, smells like, what it's doing physically. And you might say, hey, there's no change here. Yeah, it went from a solid to a liquid, or it smells really bad now. It didn't smell before. Those are all observations. It's a different color. Is this a physical change or a chemical change? That's the deal. All right, what is an MSDS? Well, as I said, it's a material safety data sheet. That's a question on your exam. And basically, it's SDS is basically simply a safety data sheet. You're taking away the M. It's potato, tomato, tomato. Let's call the whole thing off. Basically, hazards can be identified on this thing. First aid tells you what to do if something happens, basically. Is it flammable? What happens if you spill it? Where do you store this stuff? Personal protection, what you should wear. Reactivity, how reactive is it? Toxicology, the study of how toxic it is. These are useful for that. Disposal procedures, which is a huge one. I'll see a lot of this or hear a lot of this when students don't know where to dump things out. Or can you, or where do you? In biology labs, there's a lot of biohazards and those bio bags that I put stuff in after a dissection, and it goes into technically a special place to avoid some biological hazards. And down here, there is this MSDS explanation, and that is in virtual classroom. Again, not going to do a video within a video. Although I've done it before, depends how cool the video is. I might find my own. All right. So watch the video, take good notes, and if you need to stop here, do that now. You can pause this. It's an amazing technology we have these days. The image above, which is actually to the right, you can tell that I copied and pasted and adjusted this. Basically from Virtual SC, thank you guys at Virtual SC, by the way. Take a look at the full version of the MSDS. Okay, so it's hydrochloric acid. You're going to see some examples. There's more than one page. Okay, it says one page here, but you can see the things it kind of tells you. Not combustible. Use extinguishing media appropriate to the surrounding fire. If it's on its own, not combustible. So so that isn't really well defined, but it will. Handling accidental release, what you should do, what to avoid, first aid procedures. Should I pour a base on it? Should I pour water on it? Should I put a blanket over it? Is it a chemical, whatever, electrical, whatever? So basically, this is the article. You can also read for more information. And when in doubt, question or go research some things, read some stuff, and before you do something. But you might think to yourself, wait a minute, there's time constrictions. I have to get this done by the end of the class. Well, stay after school. Ask a teacher if you can stay. Or just say, hey, this is how far I get. These are the observations I made. How can I do this? And get good lab partners. That helps too. And get roles too of what you have to do, what they have to do. Here's some questions for you. 1, 2, it asks you another name of these things that's easily researchable. All right. You might say, hey, it wasn't in the. Yeah, it is. It's out there. You can research that stuff. And you're looking at what happens how to neutralize an acid. But wait, we haven't had that yet in this course. Yeah, I know. We will. But, what does it say in the MSDS? So you find that MSDS we had in the previous slide, and you go look that up. It's provided for you. I know there's a lot of information there. So you have questions 3, 4, and 5. Basically, you're looking at, if he pours it in his eyes, what do? You pour it out. Where do you pour it out? Basically, as you're following the MSDS, is what's not correct about the MSDS. And some of these are specifically difficult to pick out. You have to go looking and maybe outside research and materials. So now we're at 1.3, chemistry laboratory equipment. This is what it says here. Basically, if you have looks like a cup, which, by the way, is coffee. It's provided by coffee. It tastes like coffee. 1.3, laboratory equipment. That was a coffee mug. This is not a laboratory equipment. See, that's a coffee mug. All right. So that's basically, you don't pour it in a mug. No comment. So types of laboratory equipment. Basically, it's used in a laboratory. You don't need to be used safely. Not only do they need to be used safely, sorry, I misspoke there. They must also be used correctly. Okay, so basically use the tools for what they were, used for. But wait a minute, they're all, look at these, 3 or 4 or 5 or 6 things here. Well, they all collect liquid or can. So why can I put this one, the liquid in here, and use it for certain things? And why is this one used? This one is good for swirly stuff, and can also heat if it's Pyrex or heat resistant. And this one, why would I use this one instead of that one? And there's different reasons. And lab techniques include procedures and equipment used. What do you mean by techniques? Well, how do you successfully swirl this Erlenmeyer flask, and not do it wrong, or what are you looking for when you do it? How do you streak a petri dish with bacteria to may help it grow better? What's your technique there? Is practice. Well, wait a minute, I've never practiced something before. Well, just know that and watch some demos. Techniques follow scientific method. Scientific method is something we'll explore and learn in upcoming. Gosh, how many times a year when you take science classes have you learned the scientific method? And there is a new and improved thing called the STEAM process, which includes some of the concepts, just a little different spin. But I'll continue with this chapter. I'm not going to move ahead. And so, basically, glassware that we use in the scientific labs here at high schools or any academic setting in the lower below college, you have equipment such as lecturized computerized machines such as particle accelerators shown below, and I don't have that picture on here. It's in Virtual SC. But what I'm trying to get at is there's some really higher advanced stuff like a pH strip. That's a base acid indicator. Turns red if it's an acid, if it's that way. But there are some electrical pH meters that can get 2 decimal places of the number that you're looking at. So there are, just because you use it in a lab, it might not be what you see in real life, or maybe in other places when you go to school, in college, or whatever else you go. Now, and there's a particle accelerator right there. There's a good movie I watched yesterday about a particle accelerator. I'm not going to give you that. Go search them. Equipment commonly found in biological labs. Okay, so there's different types of equipment for different disciplines in science. Some cool ones too. These PCR machines, polymerase chain reactions, which is DNA replication. You use them in forensic science and things like that. Okay, back at it. We had to change slides here. Apologize for the issues with the microphone. So we're going to go back to this. I'm going to share an entire window here. So we're looking at examples of laboratory equipment. You're going to watch the video playlist. You're going to learn more about various chemistry equipment. There are 2 videos. So video 1, you have this science lab equipment. That should take you through, and you can stop and answer the questions that I'm going to show you that are available to you in Virtual SC. Thank you to those guys. How to light a Bunsen burner. Well, that shows you how to light one. And that's not the only thing that you can use in a lab to light stuff. So in Virtual SC, you'll be matching these up. And this sip of coffee is brought to you by the people that made this coffee. Mixed with certain blends from Hawaii, Colombia, and it tastes like coffee. So, speaking of coffee, you're going to match these things up. So these might be very simple for you to do without even looking them up. Some of them might be a little obscure. I'm not going to give you the answers, of course. And then this is the last slide. Thank goodness you're done with this. The triple beam balance gizmo. Okay, so there you go. And if you're having trouble getting into Gizmo, some people are. That's fine. And I'm going to get out of this. Excuse me, I'm having issues with the cough. You might get that every now and then because, well, it's dry out now. And, I get a little bit of allergy stuff going on. And you might too. A special thanks to for making education fun, Bitmoji, Fort Mill School District 4, Catawba Ridge High School, YouTube, Smithsonian NOAA, the Coldplay Instrumental provided by Coldplay Instrumental on YouTube. Please subscribe. Song Yellow, artists Coldplay, album Yellow, writers world champion Chris Martin, John Buckland, Guy Berryman, licensed YouTube, WMG, behalf of Plug UK Frontline, and so on and so forth. Thank you guys for those contributions. And we'll take that as a donation from you. I appreciate it for that. Without that, this video would not be fun because you have to listen to me and look at me most of the time. And, well, I have a face for radio. I apologize for that. Sorry, I'm not better looking. Anyway, hopefully you guys enjoyed your time here, and we'll look forward to that. Good luck in your test on Friday. And take care. Stay safe. Live simply. Love generously. Care deeply.